Hello everyone. So today we are solving this problem, find the length of the longest common prefix. So let's read the question. You are given the two arrays with the positive integers, array 1 and array 2. So they have the positive integers. So what we have to, a prefix of a positive integer is an integer formed by one or more of its digits. So simply like if we are given 1, 2, 3 and we are given 1, 2, 3, 4, 5, then 1, 2, 3 is the common prefix here between this guy and this guy. Okay, so what we have to do is basically a common prefix of two integers a and b is an integer c, such that c is a prefix of both a and b. Got it? Okay, fine. So for example, here you can take these two numbers 5, 6, 5, 3, 5, 9 and 5, 6, 5, 5, 4. So 5, 6, 5 is common, right? So 5, 6, 5 and 5, 6, 5 is the one of the prefix here. Okay, so that should be clear. So what we have to do is we have to find the longest common prefix from all pairs, the pair from array 1 and array 2. First pair should be in array 1 and second pair should be array 2. So all combinations would be there and we have to find the longest common prefix. Okay, so for example, we can see here, see here, if we compare this guy with this, only one is common. If we compare this 10, so 2 is common here. But if we compare 100 with this 1000, 3 digits are common. So 3 length prefix should be answer. So this is what we have to do. So let's understand what would be my approach. So one simple approach could be like I can generate the prefix of all these numbers and store them in a hash set. Okay, like this. Let's say this is our hash set. So we will generate first the prefix of this guy. So first we will, if we start from end, first prefix would be this entire number itself, like 100. Okay, then we can start from this location. Then 10 also would be a prefix here, right? And then 1 is also a prefix. So far 100, 10 and 1. Now we will come to find the prefix of this guy. But see here, this prefix is already contains here. Okay, then we should not go for the further things, right? Because this prefix is already there. Okay, now we can come to here. This guy is also already there, right? So we have, this is the set of prefixes. Now what we will do is we will come to here, okay, and we will look for all the prefixes which are coming from this guy, or all the arrays of this guy, and we will check which of them is common. Okay, and if they are common, we will get the length of them. For example, 100 would come here. So 100 is the one of the prefix here when we come to this guy. And does it contains this set? Yes, it contains. So we will note down the length of it. So its length would be 3, right? Its length would be 3. Then we would go to so yeah, 3 is like, then we will prepare one more prefix of it, like 10 would be another prefix of it, right? So does it contains? Yes, it is there, but length is 2 only. So we are looking for the max. So we will not accept this 2. Still the answer would be 3 only. Now we will come to another prefix of it. So another prefix is 1. Does it contains? Yes, it contains it. This, but its length is 1 only. So we want the largest one. So 3 would be our answer. But there is a problem in this way. If we do, not big problem, but every time, see what we are doing, we are generating the prefixes and then we are storing them into this hash set. Okay, so see here, every time we are dividing to get the next prefix, we are dividing by 10, then we divided this guy by 10. So basically we are dividing the existing integers of the array 2, right? So in this case, what will happen? Basically, it will take the n log n time complexity. Okay, but we want to do in linear time complexity. So hash map approach you would have got, but my entire code and our approach would be with the trie. I will tell you why trie. So I am taking a different example. So this is my array 1. This has, these are the numbers, and this is my array 2. These are the numbers. Now first of all, let's understand why trie. So trie, in case of trie, basically we can store and search efficiently for the characters of a string. I mean the strings basically. So that is why I am using this thing, and every time we are not dividing by 10 in case of trie. So how does trie is very simple data structure, especially for storage of the strings. So let's say first of all what we will do, we will store all the prefixes of this guy, of this array 1, right? So doing this with trie would be very easy. I will show you, it's very interesting as well. So as you can see, this is our trie, okay, or this is of size 10. Why it is size of 10? Because we have these characters starting from 0 till 9 only. We are not looking for any alphabetical stuff, right? Only 0 to 9 all these numbers would be having. So we will store together, okay. So let's come to this guy first, 1. So where it would be fall? It will go to 1, right? Because it is starting with 1, okay. Then what is the next? Next is going to 2. So where is the 2? 2 should be here, right? So its reference will be going to here, okay. So this guy would be coming here, 2. Now come to this guy 3. So 3 would coming here, right? So 3 would be coming here. Now we have 4. So this 3 is here. Now 4 would be coming here, right? So we store so far 1, 2, 3, 4, right? Now we will go to this guy 1, 3, 5, okay. So see here carefully that when we are coming to 1, 1 is already there, right? So whenever we're gonna store, we have to start from here, okay. So then only we will proceed further. So now you can see here 1. So here we are at here. So 1 is already there. So let's go for the next. So next is 2, okay. So here, sorry, next is 3. So we will go to 3. So 1, does it go to 3? No, it is going to 2. So then we have to have a reference for 3 as well here, right? So here it would coming like this, okay. Then we will come to 5. So from 3 to 5, is there something else? No. So we have to come 3 to 5 like this. So 5 would be stored like this. That's it. 1, 3, 5 is also stored. Now we are coming to this guy 4, 2, 8, 9. So we'll come to very first. So 0, 1, 2, 3, 4. So 4 is somewhere here, right? So we will keep it 4, and then next is 2. So our 4 reference will come to this guy 2, right? Then from 2 to 8, right? 2 to 8. So 2 to 8 would be somewhere here, right? So there would be one reference to here like this. Then we have 9. So 8 is going to directly 9. So this guy would be coming to like this 9. And the next of them would be for the null node, right? So I'm not just drawing those null nodes. So this is very simple way of storing. See, you can see here this one came 2 times, but we accommodate only in single one here, right? Only single one is accommodating for both of them, right? So this is a very efficient way to store and to manipulate over the string operations. Now we have stored the things. Now next thing is we have to compare them, right? We have to compare the prefix. So anyway, when we are starting from very first, whatever number is coming in our way through these reference, that would be definitely make one of the prefix, right? So in that way we will go. So let's take first one, okay. Initially so come to here. So this guy is 1. So 1 is matching, right? 1 is matching on very first. So our as of now the length is 1. Now we are coming to this guy 2. So 2 we have to check here, right? So 2 is also existing. So we will add one more thing. Okay, so 2 is also existing. Now we will go to 8. Does 8 is existing there? Yes, 8 is also existing from 2, right? But this 8 reference is not coming from here, right? This reference is basically is coming from 4 to 8, not from our starting position. Okay, so here what will happen? This is not a match. So total so far we have found how many? We found 2 only. Now we will go to this guy. So 1 is there, yes. 2 is there, yes. Then 2 to 3 is there, yes. Then 3 to 4 is also there. But 4 to 5 is not available in this series, right? So we have this time 4, okay. Now we'll come to this guy 2369. So 2 is there, no, 2 itself is not there here, so we will not go for any compare. This would be written as 0 only. Okay, so how many we found? What is the max here? 4 is the max here, so 4 should be our answer. So we are not doing any log n operation by dividing the number by 10. Okay, so for this reason now we can say that yes, this is our thing. 4 would be our answer. So here you might have some confusion that why this 2 is into. So I didn't wrote a separate one. Otherwise this you can also draw like this. Okay, if you don't want to take this 4, that could have gone to a separate this array, but this would have taken lot of space. That's why I colored it with different color. Okay, otherwise this could go 0, 1, 2, 3, 4. So basically every guy would be creating a different node if the reference is coming from the different value. Okay, so this is the way of trie way. Let me show you my code. So this is the preferred approach if we use the trie, because in the case of hash set we are basically dividing the number by 10, which is basically making the overall algorithm as n log n. Okay, so let me show you my corresponding code here. So guys, first of all you can see how I'm constructing this trie. This is my trie node class, which has children equal to of 10 size, right? For the same reason that we have 0 to 9 digits only. Now see here what I'm doing. This is my class trie where I would be writing my methods of insert and search. Okay, so see here what is happening. I just took one variable here, one class variable of type this guy trie node. Okay, so I took this guy trie node root equal to new trie node. Now I have written one method, insert method. So basically when we are inserting, we are taking them into the integer form, right? That's why my parameter is int num. So see here I have taken this node equal to root, this guy, in a different variable. Why I have taken this in a different variable? Because when you will go inside it, we will store, let's say our reference of this parent is root, but when we will go inside we will keep on going deeper, right? So we just cannot modify the parental name. That is why I am taking that in a temp variable. Okay, so see here I have taken this in node, this value. Now we are what we are doing here is we are inserting it. Okay, so I just converted this string this number to the string, right? Then I'm going to throw the every care of it. So we are taking the corresponding index value, and see here we are checking that if node dot children I equal to null, then we are making the node value with this value. Okay, just like this. When we came here to store 1 again, we found that yeah, 1 is already there. So that is why we again move to the next pointer. See here. So if it is null, then only we are adding the value. Otherwise what we are doing? Otherwise we are moving to the next node value, right? Deeper value. Okay. So far this is insert. Once we are done with the insert of all the numbers, we are done for the insert part. Now we will look for the search part of it. See here is my logic of to search. So let's say we are searching for this num in our node, which we have already stored in our trie. So see here what we are doing. First of all, I have converted our this num to string, so that we will go through all the characters and we are getting the index value. Now see here, if we are finding that node dot children I, if it is not null, that means the number is available, just like here, right? We came here 1, then we came on 2 is not null, so we started increasing value, right? So same way I am doing here. So see here, when this is not equal to null, we are increasing the length. Otherwise what we are doing? Otherwise we are breaking, because if something is not available, that means we are done. Till that point only we are finding certain prefix. Then we are returning this max length. Now we have written these two values. Okay, inserting of the values into the trie and searching of the prefix. Okay, Then we will look for how to use these two methods in our main method. So see here, this is our main method, right? So I just created one try variable and its object. Okay, now see here, I am storing all the values of array 1 into this try using the insert method. So every num we are calling insert method, so it will store. Okay, like we stored all these guys into the same try. So same way we are doing. So after storing, I just created one variable for the longest thing. Now see here what we are doing. This is the place we are looking for the array 2 values. And what we are doing here, we are using this find longest prefix. So we are getting the max length for whatever num is coming currently. And then we are checking. We are taking the maximum of max length and the longest so far. Okay. So finally our longest would be our answer. So let me execute my code. So I'm executing my code. Yeah, so it is accepted. It is faster than 91.99%. So this is taking 34 milliseconds. But see here, you can see these are the approach which I used using the hash set, which is taking 276 milliseconds. So it's a big difference, right? So that is why we are using the try. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.